Hello, Math Humans. We're going to do 7.2b today. We're going to be talking about our revolved solids again, and then today we're going to talk about the washer method. So our objectives are exactly the same, that we're going to find the volume of a solid of revolution using the washer method. So let's talk about a washer. So a washer looks like this, okay, or a donut. Donuts sound more fun. But if I want to find the area of the shaded region, if you'll remember from geometry, the area of the, I'm going to call it a donut, we'll put a washer underneath in case you want to think about washers instead of donuts, okay, is equal to the area of the hole minus the area of the hole. So that's going to be really important as we talk about our revolved solids when we start adding holes. So here's what it would look like from a calculus perspective. So now my rectangle that I'm revolving, notice that there is a hole between the object and the axis of rotation, okay? And my artwork is going to be gross again, so if I revolve it, we'll just pretend to do it this way. So here would be my washer. That's going to be my dimension of the hole, give it some depth, and then call it good. Isn't that just amazing artwork? So the volume of this cool image is going to equal pi, because we love our pi, integrated from A to B, and it's going to be r of x quantity squared minus little r of x quantity squared dx. So this is going to be the whole, and this is going to be the whole. Alrighty? So let's just start with an example so that we can see what we're doing. So for example number 1, I want to, and I'm going to write it once today, and then I think I'll skip some of the verbiage because they're the same on every problem. So find the volume of the solid formed by revolving the region bounded by the graphs. I guess if I was smart enough, I could have written all this out ahead of time, but what are you going to do? And y is equal to x squared, and again, they always have to tell us about which axis, the x-axis, okay? Alrighty, so I'm going to draw my image because it's always important to see what we're looking at, okay? And again, I'm sorry, I can't sketch these for you. So I have y is equal to the square root of x, so that is that curve, and y is equal to x squared is that curve. So this is y is equal to x squared, y is equal to the square root of x. I'm going to be revolving about the x-axis. So this is the image that's going to be revolved. The book has a much better picture, and this is going to be the whole, okay? So I'm going to have, let me put my little representative rectangle in there. I have a dx. This point is 0, and this point of intersection is going to be 1. I'm revolving about the x-axis. I have a dx. So now when I set up my equation, I'm going to set it up using my variables in terms of x. So the volume is equal to pi, and I'm just going to write this for right now, r of x squared minus r of x squared dx. So this is the whole. So the volume is going to equal pi, and I'm going to integrate from 0 to 1. So the way I think about it is this is my whole, okay? And so it's going to be that top curve, the square root of x minus 0, which is the axis of rotation, quantity squared, get a different color, minus the whole. So if I take away the whole, the green, so it's going to be minus x squared minus 0, quantity squared, and then put the whole thing in dx. So for right now, the reason that I'm showing it to you in colors is so you can think about whole versus whole. So this was my whole, and this was my whole, okay? Boy, can't you tell the difference between those two words? And now if I clean that up a little bit, I'm going to get my volume as the integral from 0 to 1. Radical x squared is going to be x, and then x squared squared is going to be minus x to the fourth in parentheses, and then I would have dx, and then the solution is going to be 3 pi over 10. So the volume is equal to 3 pi over 10. Okay? All right, let's do another couple of examples. Okay? So for example number 2, and again I'm going to skip my some of the verbiage. So we have the volume is equal to what of a solid, and we're going to revolve about the x-axis. I'm going to be given y is equal to 2 and y is equal to 4 minus x squared over 4. Okay? Well, if I graph those, okay, so here we go. Alrighty. This one has a y-intercept of 4, and it's going to be an upside-down parabola. It's going to be a fat little sucker because his vertical stretch factor is a quarter. So this is going to be y equals 4 minus x squared over 4. Y is equal to 2 is right here. So this is y is equal to 2. This is the region that's going to be revolved about the x-axis. Noticing now that I have a hole, okay? And so my points of intersection are going to be a negative 2 radical 2 and 2 radical 2. And I'm assuming that you can do that math. Here's my representative rectangle. I have a dx, okay? So now I'm going to set up our volume. So the volume is going to equal pi, integral from a negative 2 radical 2 to 2 radical 2. Those could also be decimals. It doesn't matter whether you're doing radicals or whatever. So here's how I'm going to set this up. I'm going to do the whole, okay? So I'm going to do my top curve, which is 4 minus x squared over 4 minus 0. And this is important. I know it seems redundant, but I'm showing that I'm setting up the whole quantity squared minus, and then I'm going to do in a different color the whole, which is going to be 2 minus 0 quantity squared dx, okay? And so if I simplify, my volume is going to equal pi, integral from a negative 2 radical 2 to 2 radical 2. And I'm going to get 4 minus x squared over 4 quantity squared minus 4 in parentheses dx. Push buttons on my calculator because I can, and I'm going to get that my volume is 132.694. Okay? And again, it's a symmetric image about the y-axis, so I could have integrated from 0 to 2 radical 2 and doubled this. Okay? But 6 of one, half a dozen of another. The biggest thing that I need you to understand right now is I'm doing top minus the bottom, which generates the whole thing. Right here, this would be the whole. And then I did top minus the bottom for my whole. Because as we move things around, these problems become a little bit more entertaining. Alrighty. Example number 3. Again, I'm going to use my shorthand. So I want the volume of the revolved solid. I'm going to revolve about the line x is equal to 5, which is cool. And then I'm going to have y is equal to 5 minus x, y is equal to 0, y is equal to 4, and x is equal to 0. So the first thing that I'm going to do is graph my region. Okay, so this is the same thing as a negative x plus 5. Okay, so 1, 2, 3, 4, 5, and this guy's going to go this way. Okay, and then I have the line y is equal to 4. So I'm going to draw that one in there. So there's y equals 4. This is y equals a negative x plus 5. Y is 0 and x is 0. So I have this weird little truncated image. Okay, this x-intercept is actually 5. And I'm going to do it in a different color. I'm revolving it about the line x is equal to 5, and there's where I'm revolving. So here's my cool little truncated triangle. It's kind of a trapezoid. It is a trapezoid. And I'm going to revolve that about a vertical axis. Okay, so there's what I'm revolving about. And then that means that I'm going to have a dy. Okay, so because I have a dy, I know I'm going to have to solve this equation for x. So I'm going to get a negative x plus 5 equals y, a negative x equals y minus 5, x is equal to 5 minus y. Okay, alrighty. So in this one, I have a hole right here. Okay, so when I set up my volume equation, I'm integrating. This is 0. This is 4, because that's y is equal to 4. I'm going to integrate pi from 0 to 4. So this one, my hole, is going to be the big rectangle. So it's going to be 5 minus 0, quantity squared. And then when I do the hole, I'm going to do 5 minus y, quantity squared, and then I have my dy on the outside edge. Okay, so let's talk about this again. Here's the 5, right, minus the left. If I take out the whole, it's going to leave the image, right? I'm going to clean this up just a little bit. Here's my pi, integral from 0 to 4, 25 minus, and then I'm just going to leave this as 5 minus y, quantity squared, and then there's my outside parentheses dy. I would highly recommend that you be extra careful when you're putting this into your grapher. You could simplify this if you wanted. When I simplified it, I got integral 0 to 4 of 25 minus y squared, and then in parentheses dy, and I'll write it up here because I'm at the bottom of my page. So my volume was 247.189. So again, it's important to think about what we just did. We revolved our image, this little trapezoid, about the vertical line x is equal to 5. My whole thing is this rectangle, 5 minus 0, and then I took away the whole and I did 5 minus this curve. That's the area of this region. When I take the big rectangle and I subtract the whole, it leaves the area of what I want. Alrighty, that is it for today. I will see you soon.